All right. On this problem it says f of x is sine x over x. Determine the equation of the horizontal asymptote of the graph of y equals that. Okay. Determine the equation of the horizontal asymptote. In pre-calculus we kind of talked about a little bit what a horizontal asymptote is, but not that much. So here's how to get a horizontal asymptote. Let me write, it's kind of like notes here. So horizontal asymptotes only apply to end behavior of a graph. And what I mean by end behavior, I mean like stuff happens in the middle, but like towards the end, towards way out when the x values over here get very large, or when they get very small, that's when horizontal asymptotes like are obeyed. In the middle of a function, anywhere in the middle, you can cross a horizontal asymptote. You're not allowed to cross a horizontal asymptote way out in the ends. So, to find your horizontal asymptote, so to find your end behavior, that's what it's called, you just take the limit of the function as x approaches infinity. That's what's happening to the function, what is it getting closer and closer to as the function goes way to the right, and what is happening to the function as you get way out to the left. That's really all horizontal asymptotes are. It's just end behavior. So, here it says determine the equation of the horizontal asymptotes. Well, these are horizontal lines, so we're going to have y equals something. Okay, that's good, yeah. And then, yeah, all we do for that is to take the limit from each side. Sometimes you may have an equation, so like here's the graph, or the xy coordinate plane. You may have an equation that does something and then goes to a horizontal asymptote down here, so that's like y equals, I don't know, -3, and then does something and then goes to a horizontal asymptote up here. So it has different horizontal asymptotes from each side. I don't know, +3, whatever. These would have two asymptotes, or that's probably going to be a piecewise function if it does that. But here, in our case, it's probably going to be the same just because they only give you one option. It doesn't have another equation there. So, horizontal asymptotes, to find them, you take the limits as x approaches infinity. So what we're going to do is take the limit of that as x approaches infinity. This is kind of a tricky one, but I had something like this on the notes. Limit as x approaches infinity of sine of x, over x. Now, the output, so aside from this is like a side note. For y equals sine of x, the graph of this function just oscillates back and forth. The highest that this function can be is a +1. The lowest it can be is a -1. And it just goes on and on forever. It never really gets, it absolutely never gets bigger than 1, and it never gets smaller than 1. Alright? So, if I plug in like pi over 2, let's just plug in like actual numbers, not just pi. If I plug in like 1.5, I get something, I get maybe that, okay? So I get some value. If I plug in like 3, I don't know what happens, was maybe something like that. I get like a negative number out. But like no matter how far I get out over here, I'm never going to get something like -20 or something like that. I'm never going to get that. I'm never going to get a +20 or something like that. I'm always, anything that I put into my sine function will always come out to be in between -1 and 1, including -1 and 1. So, that's important to realize. So as x gets really big, sine just bounces back and forth between 1 and -1. So this is either going to be -1 or somewhere in between, never growing bigger than that or smaller than that. However, the x is going to go to infinity. It's going to blow up. It's going to be super huge. So, that's kind of like we can compare it to this. If the top is staying the same and the bottom is going towards infinity, then the whole entire fraction goes to 0, right? The top is staying the same, the bottom is blowing up, it's getting huge, then it dwarfs the whole entire fraction. Well, since sine only stays between -1 and 1, it's kind of like it's not going anywhere, especially when you compare it to something really, really huge. So these sine of x over x is close to, it's kind of like 1 over x when x approaches infinity. Okay? Because the whole entire thing goes to 0. This is staying relatively small, and this is getting huge. This is staying small, and this is getting huge. They're kind of similar in that case. So, if we, this is really, really scattered, but if we have the limit as x approaches infinity of sine of x over x, this will approach 0. The thing is, this will go back and forth between being positive or negative. If you graphed this, it would look something like getting closer and closer, oscillating around back and forth until it's just getting closer and closer to 0. And then on the other side, it would go and do the same thing. So the end behavior is tending towards 0. That's what it's saying. So the horizontal asymptotes for this, or the horizontal asymptote, is y equals 0 because the limit at infinity is 0. That was a long explanation. I hope that makes sense. To get a horizontal asymptote, you take the limit as x approaches infinity or negative infinity. Bandada. I really hope that helps. I tried to explain it. Whatever.